plot thickens as the gold leach reaction occurs in a heterogeneous system consisting of gas, solution, and solids. For heterogeneous systems, the rate limiting factor is diffusion, which I call the final frontier. This is the final challenge that we have to overcome once the chemical conditions have been satisfied. This is where lances and sparges and injection systems with a low degree of mixing fall short, and where the MACH comes into its own. The extreme energy release in the MACH from cavitation cleans particle surfaces and improves liberation, while also accelerating mass transfer and diffusion to improve leach kinetics and recoveries. If one looks at the slide, the green curve depicts the boundary layer, which is in fact a clear water layer, which surrounds the particle. Cyanide and oxygen will have to diffuse through this layer to the reaction surface, and orocyanide would have to diffuse back out through this layer for successful leaching to take place. The MACH drastically reduces the thickness of this boundary layer to speed up diffusion through it and accelerate kinetics. If there are also still porous reaction layers on the particle surface, then this extreme mixing condition within the MACH will also speed up diffusion through these layers. These theories that I've just put forward are well supported by literature, including this excerpt from the book Stanley, Volumes 1 and 2, which was my go-to reference while completing my metallurgical graduate internship with AngloGold Ashanti all those years ago. What it says is that oxygen helps, pressure helps, increased agitation helps, as well as elevated temperatures. All of these conditions are satisfied when we add cyanide to the Mach reactor as well, for a boosted leach ahead of carbon absorption. Some plants manage to achieve circa 80% of the recoverable gold in a single leach tank, using the Mach reactor ahead of the absorption circuit to create a leach and absorption profile similar to that of an old school CIP plant. A desirable situation which provides for high carbon loadings for elution and low soluble losses as the leaching is complete very high up in the leach train. Some precautions have to be taken if there are preg robbers present in the ore. This is typically the result that one obtains when the Mach is used in a boosted leach application. Very rapid initial leaching with an incremental recovery improvement as well over the base case. Typically, we would only require 30% of the traditional residence time with this approach, and improved kinetics is almost always guaranteed. What is a little harder to achieve is the incremental recovery improvement, which can vary quite considerably from ore body to ore body. On some mineralogies, we are able to obtain a very marginal benefit, while on others, the benefit can be quite significant. Laboratory testing and plant trials will be required to ascertain the potential benefit for your specific operation. By far the most impressive application of the Mach reactor in gold leaching is that of the improved recovery of semi-refractory ore bodies. GoldOre has a couple of applications of the Mach reactor on semi-refractory ore bodies on full plant scale, where a partial breakdown of the sulfide matrix is achieved in a very aggressive pre-oxidation at high Mach passes with oxygen and lime addition. Temperatures in the range of 70 to 85 degrees Celsius are obtained, and leach recovery improvements are in the range of 6 to 10%, with vastly improved kinetics and also reduced cyanide consumption. For these types of ores, where the gold is mainly very fine-grained with a small proportion of solid solution gold, the application of the Mach is an attractive and cost-effective proposition and a viable alternative to other more expensive refractory ore treatment processes. So onto the practical aspects of how to implement and install the Mach reactor technology on your plant. We would typically run the Mach reactor on recirculation on a leach tank without carbon. This tank may or may not have cyanide, depending on whether it's a pre-oxidation or boosted leach application. Where we may have the luxury of a second leach tank available to us, and provided that there is no preg robbing, then we may also run the Mach with cyanide on this tank for a boosted leach ahead of carbon absorption. Where all tanks have carbon, then we can run the Mach in line on the line feeding into the first leach tank to provide for a one-pass system either with or without cyanide. Where there is preg robbing present, the Mach may also be run on leach columns, which is simply a pipe column with low residence time, which is installed ahead of the carbon tank and with the Mach on recirculation on the pipe column. This video not only highlights the design benefits of the Mach reactor, but also the installation on recirculation on a gold leach tank. There are other applications for the Mach reactor as well, such as cyanide destruction, where we run the Mach on recirculation on an SMBS air detox tank for improved mass transfer, circuit performance, and reduced reagent addition. The Mach may also be employed for AMD treatment and arsenic remediation. Various other hydrometallurgical processes, such as uranium and base metal leaching, may also benefit from the increased mass transfer of the Mach reactor. Iron and manganese precipitation in base metal processing also comes to mind as a potential application. There are semi-pilot Mach reactor test rigs available at Mintech and at ALS in Perth, and soon also at SGS in South Africa, where test work with a 2-scale model of a Mach reactor may be performed. Initial scouting work that tests a base case together with a couple of different Mach passes would require circa 50 liters of pulp and would cost in the region of $10,000 to $15,000 US. Not a lot of money to ascertain whether you are likely to see a benefit or not, and a no-brainer in the light of the incremental monthly profit that could be attained. There's a range of sizes of Mach reactor available, from laboratory units that do 0.45 cube an hour to full-scale units that do 3,000 cube an hour through a single unit, and everything in between. If there is a specific size that you require that is not already available, then a custom design can be done for you. 2-month free plant trials can be arranged, where the Mach is supplied free of charge for the trial period, with the installation costs borne by the client. It's a fair arrangement with low risk for the client that allows you to assess benefits directly on your full-scale plant. Mach reactors may be leased or purchased at competitive prices. The cost of the Mach reactor is usually in the range of 10 to 20% of the benefits obtained. Good business for you as well as GoldOre. Well, we have unfortunately reached the end of my presentation. I hope that I have given you enough compelling reason to assess the Mach for your operation. GoldOre is always willing to assist and collaborate where necessary to come up with a tailored solution for your specific needs. I thank you for your attention.